It's getting colder, and you know what that means. Time to swap out summer green for a winter-themed Compute Module 4 clone. Seriously, there are almost a dozen Compute Module 4 clones now, and I have even more on the way. But what, pray tell, is a Compute Module 4? It's this thing. And this and all the clones are entire computers on one tiny little board. But there's no USB, HDMI, none of that. That's because these are all system-on-modules, and they're used for anything from portable gaming emulators to smart lighting to industrial control systems. You plug them into another board, and that gives you the I/O, display, controls, or whatever else you need for a full custom computer. It's been a while since I mentioned the Compute Module, and that's because it's been literally impossible to get one since like early 2021. In fact, I ordered a few a year ago, and DigiKey just delivered them this week. So that was annoying. If you want one, go check out rpilocator.com. Supply is finally coming back to pre-pandemic levels. Even still, there are a lot of people saying, who cares about the Raspberry Pi? There are like 50 other boards and they're so much better. And I mean, you're not wrong, but better how? Objectively, being able to buy a board makes it better. And most of these little guys were definitely able to be bought, so yes, that's better. And a few of them even have pretty good chips on them, or extra features like this little Rock 3 Compute Module has a whole extra set of I/O that the Pi doesn't. But you know what's not better? Spending a week trying to get it to boot. But that was me testing a pre-production version, so I bought a production version and still had issues. When I asked about it, they told me the version I bought isn't really as well supported right now since they're working on a newer model. Now, since then, they've released some working images, but the documentation is still pretty rough. I agree with DP Hack's take. Calling it a drop-in replacement for a CM4 is a little bit of a stretch. Some boards require a bodge wire solder job to make them work. I see the Rock CM3 more as a CM4 alternative for advanced users. But a few of these boards are better than others, and I have a lot of them listed on my SBC Reviews GitHub repo. Like, surprisingly, even though the thing is pretty slow, this Milk 5 Mars CM is fairly well-rounded. It's just that it, like every other clone here, has a few quirks that make it not a literal drop-in replacement. On one, camera support will be broken. On another, PCI Express. And in one case, different board revisions behave differently, so good luck sorting all that out when you're searching Discord and random forum posts. That's not quite user-friendly, so I still recommend just buying the original, especially since, you can now. In this video, I'm going to quickly walk through my experience with each of the CM4 clones and then talk about a bunch of new CM4 projects. To be clear, I bought at least one of all the clones in this video, but most of the other projects I'll be testing later were sent by the board designers. There are links to everything below, so let's get started. For the clones, I'm going to skip talking about performance. Some are about as fast as the Pi, and some are a bit slower. And there are a couple modules that might come out soon with even faster chips. My main goal is to highlight how each board is in real life. Benchmarks and cool features, that's one thing. Being able to buy the thing and use it is surprisingly not always straightforward. Kicking things off with that milky white compute module, this is the Milk 5 Mars CM. It's actually a RISC-V processor, the JH2110, and that means in some ways it's radically different than the rest of the clones. It runs an entirely different architecture, and I just posted a video dedicated just to this guy, so rather than bore you with all the details, go watch that. And I covered this guy alongside the Rock 3, and in that early testing I had a lot of trouble just getting this thing to boot. Things improved now, to the point there are a few images that boot right up. I was able to get Diet Pi running, and all the basic stuff worked fine. The RK3566 on here shows up on a lot of these clones, and for good reason. It's not that much slower than a CM4, and it uses around the same power. It also has a built-in GPU that's pretty decent, and a tiny little AI accelerator. And it's the same chip they used on the Radsa Rock 3 compute module, or CM3. This board, this is the one I just can't get running for the life of me. Other people did get it running, but I think I've been cursed to never get a CM3 to boot. This prototype version was one of the first Compute Module 4 clones, so I wasn't too let down when the prototype had issues. But then when I bought the light version a few months later, and even though the board was the newer revision, I could never get it booted on my Compute Module 4 I/O board. Now, some would argue that since Radsa makes their own carrier board, I should just use that. But the entire reason for these clones' existence, really, is to be a drop-in replacement. This board seems to be plagued by a few tiny incompatibilities, and from what I've been told, they're focusing on the newer CM5, which uses the much faster RK3588S. Faster and more power efficient than the Pi's chip. but it's been months since they announced it and I haven't seen a launch date yet. We'll see. Moving on to this board, I just got this last week. It's the LucFox Core 3566, and I think this thing is the result of Waveshare having like 50 really neat CM4 carrier boards, but no CM4s to use on them. I bought it from Waveshare and it shipped pretty quick, but so far I haven't gotten their OS to run on it. The wiki is a little sparse and some of the documentation seems to be Chinese first, so I'll have to keep testing. It should perform the same as the other RK3566 boards, but I was a little scared when I saw some documentation around a really old Linux kernel being used. Most other boards run the still old 5.10 version, but at least it's not that old. The ancient 4.19 version of the kernel this board launched with is riddled with security holes. Anyway, moving on to the Orange Pi CM4, it's, repeat after me, another RK3566 chip. But it used some pretty fast built-in eMMC storage, and everything on this worked out of the box for me. The documentation was a little daunting, but I found their Orange Pi CM4 bookworm image, flashed it, and it ran. Which, sadly, is surprising, but that's a good thing. It's running that 5.10 kernel, so it's not the latest, but it was stable and as fast as the other RK3566 clones. So, not great, not terrible, but at least we got options. A couple of these clones dare to be different, though. This Bigtree Tech CB one actually runs an Allwinner chip, the H616. This chip is pretty slow though, and this is the only clone without built-in gigabit Ethernet. It just has piddly old 100 megabit. The main reason Bigtree launched this thing was that they had a ton of 3D printer boards for the Compute Module 4, but no Compute Module 4 for the boards. That's kind of a theme here. They figured something's better than nothing, and voila, they made this thing. It's definitely better than nothing, and it's cheap and it worked without much fuss, so I kind of appreciate it for what it is. Also on the dare to be different spectrum, Banana Pi made this BPi CM4 with an Amlogic chip, specifically the A311D. And it's a nice chip. It's a little faster than the CM4, it has a faster AI coprocessor, and a lot of the interfaces worked right out of the box. But Banana Pi's always been a bit tricky to pin down. One time I tried downloading an OS for it and the Google Drive folder that they had was just empty. And at different times in my testing, some of the interfaces like USB or Wi-Fi just didn't work. There are fixes now, but it seems like support for this board's been hit or miss. And rounding out the clones, this board isn't actually a Compute Module 4 clone, it's a Jetson Nano clone. But I did want to touch on it because Turing Pi is just about to start shipping these things. This is the first compute module I've seen that has the RK3588 chip on it, and it's fast. It's a good deal faster than the Raspberry Pi, and for some specific use cases, it might be a better option. But it's not quite fully baked yet, they're still tweaking the software for it. I'll probably test this thing in my Turing Pi cluster soon, so subscribe for that. Okay, so that's all the clones. Now, what new projects do I have going into 2024? Well, for one, this guy. This thing's built for HMI use, that's human-machine interface, but you could just call it an all-in-one touchscreen industrial Pi computer. This reTerminal DM is the big cousin to the smaller reTerminal I've covered before. This version has a 10-inch IP65 rated touchscreen, and you can mount it to a wall, a table, or any other surface, or even a VESA mount or a DIN rail. And it comes with a bunch of industrial interfaces from RS-485 to CAN bus and everything in between. This kind of panel could be installed in machinery or in a factory for monitoring and controlling devices. It also has a fancy expansion slot where you can install a 4G modem or LoRaWAN for long-distance communications. And the model I got uses the Pi's PCI Express bus to add on 2 more gigabit Ethernet ports and an internal NVMe slot. Pretty cool. This thing is rock solid and pretty hefty too, and I'm kind of thinking it might be the perfect Home Assistant control panel for my new studio. What do you think? This isn't the only all-in-one industrial Pi machine on the market though. Remember the Chipsy industrial panel PC earlier this year? Both of these are interesting options for a completely custom panel for HMI or just displaying anything with a durable touchscreen. The reTerminal DM starts around $400, or the model I have adds on a camera and those 2 Ethernet ports for around $150 more. Next up, Magic Blue Smoke wanted to plug a Pi into a TV and hated that you needed an HDMI cable. Thus, the CM4 TV Stick was born. This is a $35 adapter that literally plugs a Pi into a TV. You could throw LibreELEC on it and have a completely private TV stick. Or you could put RetroPie on it and have a tiny game console for the road, like for hotel rooms or friends' houses. It works best with Wi-Fi since there's no built-in Ethernet, and you'll still need to supply power through the USB-C connector, but it's a handy tool. It has a built-in IR receiver, though you could also stick a FLIRC in the USB port if you want. But if you just plug it into the back of a TV, IR might not work at all, so you might also want to use an HDMI extension cable like I have here. I fired mine up with LibreElec's official CM4 image, and it worked without a hitch. On the topic of CM4 sticks, Nebra sent me their Compute Module 3 and Compute Module 4 flash sticks. I used to use my PiTray Mini for flashing eMMC Compute Module 4s or to update their bootloaders, but these flash sticks are even better for that. They're cut down to do one thing and do it well. They make flashing compute modules easy. It's nice to just pop a CM4 on, plug it into my USB port, and flash away with PiImager. It's only $12, but it's kinda like the Balena Etcher Pro that I used on the MrBeast project. It's highly specialized, and most people probably don't need to flash so many compute modules, but if you're like me and you need to flash these things a lot, having one or two of these is absolutely a no-brainer. Way off on the other end of the spectrum, Seeed Studios sent me their EdgeBox RPi 200 also. I've covered some industrial DIN rail mounted Pis before, and they're made for some harsh environments. This one has a durable metal enclosure, and the fit and finish is superb. There's thorough online documentation, and I love how the Phoenix connector pinout is right on top of the thing. It's also really easy to open up. There's just two screws that hold down the metal cover, and right away you see one of the two expansion slots. A few more screws and you can get at the M.2 slot on the bottom. There's all kinds of industrial I/O, so outside of it costing a couple $100, these types of computers are the perfect option where you need a reliable, fanless computer for automation, remote sensing, or that kind of thing. They sell options with built-in 4G or LoRaWAN, and all their models come with a Compute Module 4. One model even has an integrated UPS, and yes, this is the second product from Seeed Studios in this video. They've been busy. Now we have the PiCast. It's one of the newest PiKVM boxes, and it's also the smallest one I've tested. It has a trick up its sleeve though. If you look around at all the ports, there's one thing missing: Ethernet. Every other PiKVM box has an Ethernet port, or at least Wi-Fi, but this one doesn't. But how can an IPKVM have no networking? That's the magic of this little port. It runs Ethernet over USB-C. That's right, this port can power the PiCast and give network access straight to any laptop or tablet that supports USB Ethernet. I got this pre-built kit with everything put together, including this little OLED screen, and all I had to do was plug in USB-C to my iPad, HDMI and USB to a server, and then I browsed to 192.168.2.1 on the iPad, and bingo, there's the PiKVM interface. It also has HDMI pass-through built in, so you just need to run this command and you can turn that on. PiCast actually makes a variety of hardware options, so I'm not going to do a deep dive here. I think I might do a bigger video on all the different PiKVM options at some point. Before I work on that, I also have to test the latest BleeKVM, the V4 Allwinner version, and yes, that means it's not actually built with a Compute Module 4. It has an Allwinner H616 inside, and yes, that's the same chip the Bigtree Tech CB1 has, and yes, it's not as fast as the CM4. But it's plenty fast for basic PiKVM functionality. The key feature is it's easy to get, and you can get a whole tiny IPKVM without having to also find a Compute Module 4. And these little rack ears aren't so you can mount it in the world's tiniest and cutest network rack. They're for popping it into a full-size rack so you don't need a shelf. Or so you don't do the shameful act many of us do and let it dangle by the HDMI cord. The interface is still snappy, and I'm happy to see more KVM options. I just wish BleeCube was a bit better at working with the open source projects they use to build their products. BleeCube's had issues where they would grab code from PiKVM and TinyPilot in particular and rebadge it as their own, not respecting the license stipulations. That's not cool. It takes a lot of work to build software for these boxes, so proper code attribution is the least you can do. I'd also encourage any company selling PiKVM hardware to contribute money back upstream to the developers. It's what keeps the open source world going round. The last board for today is Johan's Carrier Board, which is a carrier board by Johan. And it's not really groundbreaking, it's mostly a tiny Compute Module 4 I/O board, but with a few changes to make it more useful as a small NAS. It's got room for a CM4, an M.2 NVMe SSD, and most of the I/O interfaces from its bigger cousin. But no warranty and no guarantee. In fact, you can't even buy this board. Johan just wanted this board to run his NAS, and he built a few prototypes, and this is one of those. He said if someone else wants to take the project and run with it, they can. He even left his contact info and a couple stipulations. I love that people who aren't even electrical engineers are designing carrier boards for the Raspberry Pi. It's really opened up people's eyes to what's possible with open source software like KiCad, and it's going to be really interesting if we can get a Compute Module 5 in the same Compute Module 4 form factor. And that's just it, really. There are so many amazing new Compute Module 4 projects out there, it's really hitting its stride now, especially since normal people like you and me can finally buy one. But with the Pi 5 just being released, everyone's already speculating about Compute Module 5. Raspberry Pi hasn't said anything except that there may be news sometime in the first half of 2024. That's great, but for now, it's a good time to start working on a new Compute Module project, even if you don't use a Raspberry Pi. Until next time, I'm Jeff Geerling.